I'm going to need you to know how to solve an exponential equation and how to solve an exponential inequality. In the past, when we've done equations versus inequalities, we can do mostly the same things, right, to solve an equation versus an inequality. What's the difference with an inequality? What else do I have to do in an inequality? Usually, shade, right? Some sort of graph, either a graph or a number line. Today it's going to be a number line, and we're going to have to shade on there somewhere. Okay? So this is stuff, excuse me, not the inequality, not the exponential part, but the solving an equation versus the solving an inequality you've already done. Okay? So earlier, some of the children in my class saw number 1 and they panicked. And I said, I will tell you when it's time to panic. Okay? If a dragon crashes through the roof and tries to lick you with his fire tongue, you can panic. You can't panic at number 1. And this is why you can't panic at number 1. If a base equals a power, a base to a power equals the same base to a power, shouldn't those powers be equal? So can't I solve this entire equation by saying x minus 7 equals 2? And you honestly think that's something you need to panic about? No. How do you solve that equation? Yeah. Add 7. What's 2 plus 7? 9. So if I have like bases, how do I solve the exponents? Yeah, I just set them equal to each other, right? And solve. How do I check to make sure this is the right answer? Plug it in, right? So what is 9 minus 7? 2. Let's pretend that's something really hard that I don't know, like 5 to the 2. I know we know it. Okay, pretend. Does 5 to the 2 power, or 5 squared, equal 5 squared? Yes. Yeah, I don't even have to know what 5 squared is, do I? I mean, I know we do, right? But we don't have to know what it is as long as it's exactly the same thing. Okay? So then they said, oh, but look, number 2. Number 2 is definitely a reason to panic.
No.
And I gave them the look. You all know which look I'm talking about. You've all gotten it at some point or another. Some a few minutes ago.
Seriously.
Okay?
Come on.
Okay? Because look, remember back here I said you got to have the same base, right? Oh, this is why we panic, because we don't have the same base. Excuse me, last time I looked, 8 was really 2 to the 3rd. Or another way to express 8 was 2 to the 3rd. Oh my gosh, they have the same bases. Again, no reason to panic. 8 is really 2 to the 3rd. And if I have the same bases, what's true? The exponents have to equal each other as well, don't they? 3x minus 4 equals 3.
Wait, so how do you put that together? That's what I don't understand.
All I did was take this exponent and write it down.
Oh, okay.
And then take this exponent and write it down. Okay?
Okay.
So then to solve this, oh, this is a much harder equation, right?
So we just add 4 on both sides?
Yeah, add 4 on both sides. Good.
So it's x.
3x equals 7. Divide both sides by 3. X equals 7/3. Excuse me. How do we know for sure that's the answer? Plug it in. 7/3 times 3 is 7. 7 minus 4. 3. 2 to the 3rd power equals 2 to the 3rd power. Yes, it does. Okay? I will do either number 3 or number 5.
Wait. Number 3? No, 5. 6. No.
The one that's harder is
6
always
was
the
not
one.
a choice. Either 3 or 5.
5.
5?
5.
Take a vote.
I'm not taking a vote.
Okay.
2 to
Which one
5.
you want?
I'm going to do
Okay,
a funny
that's
one
3.
anyways, but that's okay.
It's 3. Did you hear her? She said 5.
Are you pulling her hair?
No, it's just falling.
Okay. How about if I do the harder one?
Okay.
5.
Yes!
Does 5 look like the harder one?
Nope.
There's less things written down, right? Okay. But I want you to know when you go to do number 3 that it's similar to number 5. Fair enough?
Yeah.
Okay. So let's look at number 5. Do they have like bases? Okay, so with this is when we panic? No. Okay? And the reason it's not when we panic is because I know, and I hope you know, that I can rewrite 27 some other way. A base to a power. How can I rewrite 27?
9 to the second.
9 squared is 81.
That's what it is. That's it.
You have calculators in front of you. You can mess around with those and see if you can figure out how to write 27. It's 3 to the third, right? 3 to the third.
Oh yeah, makes sense.
Can I write 81 as a base of 3?
Yep.
How? 3 to the what power equals 81? 3 to the 9th? Put in your calculator 3 to the 9th and tell me what it says. What is it? What's 3 to the 9th?
1983.
So not 81,
No.
right?
No.
How do I write 81 as 3 to some power?
3 to some power.
3 to what power equals 81? 3 to the 4th.
Doing. Try 4. Oh, she already.
So 3 to the 4th is 81, and 3 to the 3rd is 27. The only difference is this side is raised to the x minus 1 power, right? Gosh, I wish we knew what to do when a power was being raised to a power. Oh my goodness, a power of a power? What do we do with those numbers? Multiply. So this is really 3 to the 4th equals 3 to the 3x minus 3. Isn't that what you told me to do? Multiply? So I multiplied everything over there by 3. And now suddenly, they have like bases. If the bases are alike, what else should be alike? The exponents. So 4 should equal 3x minus 3.
Now you just
Sir.
go backwards.
How'd you get the 3x minus 3?
I got this 3x minus 3 because we looked on our foldable from yesterday, the power of powers, and if I'm raising a power to a power, I multiply those two numbers. Okay? The only difference is this time it's not just two numbers, but it's this and that whole thing. So I had 3 times x minus 3. And when I distributed right there, I got 3x minus 3. Okay? So guys, how do I solve this equation?
You do negative, no, minus 3, minus 3 on both sides.
I add 3
Or
to
add
both
this
sides?
one,
Mm-hmm.
yeah.
Add 3 here, 7 equals 3x divided by 3. X equals 7/3. Is that the right answer? What's 7/3 minus 1?
So what would it be? 1 over 1?
It would be 3 over 3. Wouldn't that be 1?
Oh, yeah.
What's 7/3 minus 3/3? 4/3. Now you ready to do some math in your head?
Yes.
Okay, so right now we have 27. Let me write it down so you can see it. 27 to the 4/3 power. Yesterday, on our foldable, we said the top was the power and the bottom was the root. Top is the power, bottom is the root. What is the cubed root of 27? What times itself is 27. 3. What's 3 to the 4th power? 81. What was I supposed to get it to equal?
81.
Oh my gosh.
So that's the answer?
Yes. Here's the answer right here. Yes, sir.
Where did the 4 come from?
Which 4?
In front of the equal sign?
This one?
Yes, ma'am.
Because it's the exponent on this side.
Okay.
Okay? When the bases are the same, we can set the exponents equal to each other to solve them. See how these bases, that's a 3 and that's a 3? When they're both 3, then the exponents should equal each other as well. Okay? So if we can, if it's possible, we want to make the bases the same. Because then to solve the equation, all we have to do is set the exponents equal to each other. Okay? Please circle number 4. So far you have 3 circled. So far you have 3 circled and 4 circled. Okay? You're also going to circle number 6, and I'm going to do the first step for you, and you're going to do the rest.
Okay.
Okay? First thing I have to do is what? What did I just tell him that what we wanted to do first?
Get the bases?
Get the bases the same, right? This has a base of 5. Do you think there's any way I can make this have a base of 5?
Yes? Yeah.
Well, isn't 25 5 squared?
Yeah.
Right? Except it's in the denominator.
Oh, so you gotta make it happy.
Well, it is happy.
Oh, yeah.
I actually want to make it sad and get it out of the denominator, don't I?
So how do you
Why do I want to make it sad? Maybe today I'm evil.
Oh.
25 minus x.
So if I move this, if I have it 1 over 5 squared, what happens to the exponent when I move it to the numerator? 5 to the negative 2. Okay? Does everybody see how I got from here to here? Good. How hard has this problem just become?
No.
Not at all, right? Because now you just have to set the exponents equal to each other.
So 19.
Okay? What?
Wait.
I'm waiting.
Hang on.
You got it? No? Which part?
It's alright. I'll figure it out.
You sure?
Now we just do the exponents, right?
Uh-huh.
So, can I say it out loud?
Sure. I'm not going to write it down, but you can say
Okay,
that
would
loud.
I put like, would it be negative 2 equals x minus 5?
Yes.
Okay, I got it now.
Okay. So what happens if it's really not easy to get to a common base? Or maybe you just can't figure it out. So that's when we cry and just go to bed?
No.
No. No.
Just smoke some more drugs.
Okay?
Keep doing it.
Now please also don't smoke drugs at that point.
Oh,
Okay?
yeah, that's right.
I want you to look at the calculator. Okay? Look at this problem right here. Now, I'm showing you an easy one. Fair enough? Okay? I'll show you a harder one in just a second, but let's look at the first one. Why am I saying this is an easy one? Yeah, the bases are already the same. Okay? If the bases are the same, how do I solve it?
Just the exponents.
The exponents. Set the exponents equal to each other. So 2x minus 4 equals 2. So I would,
Add 4 on both sides.
very good. Add 4 on both sides. So 2x equals 6. So x should equal 3. Okay? So you know how to solve it algebraically now, right? I want to use this one that we already know the answer to and show you how to solve it with the calculator. Okay? Hey, grab me one of those too so I can use a color one on the video. Please. I mean, I have mine. It's right here, but it's not a color one. Thank you. Okay? So, the first thing I want you to do is go clear out everything from your calculator, people, before you didn't do that. Please.
How do you do that again?
Menu, actions, delete all. That's how you do it on the scratch page, like on the scratch pad. Otherwise, from documents, just create a new document that's a graph, and it'll be a fresh one.
I don't have to delete all, but I have to clear history.
That'll work. Okay. Okay, so here's my graph right now. How we're going to solve this with the calculator is I'm going to enter 3 raised to the 2x minus 4, and then I'm going to press enter. I know I only put one side in there. That was on purpose. Okay?
What'd you do?
I either hit tab or that line was already up there, the entry line, and I entered one side of the equation. In this case, the left side of the equation. Okay? Pardon? I just entered one side of the equal sign into the entry line. Okay, so far? What do you think I'm going to enter in f sub 2 or f of 2? The other side, right? Okay, so I'm going to enter 3 squared because that's the other side. All right. Now, just so happens they gave us a graph that it should look like, because this is an example. It's a sample problem. Does my graph look like theirs?
Sorta.
Sorta, but not exactly, right? What have I not done yet? I didn't change my window, okay? They gave me a sample window. Regardless, if I don't have a window to look at, to use, I need to be able to see everything. Right now I can only see one of my parts. I know I've got to have 2 parts because I put 2 things in, okay? So I'm going to go to menu and change my window. I'm going to edit my window settings. And I want it to be exactly what they asked it to be. I want it to go from -1 to 5, and I want it to count by 0.5s. I want my y values to go from -1 to 10, and I want it to count by 1s.
Wait.
I'm waiting. Menu, window.
My graph? Or my deal went this way.
Let me look at it real fast. Now when I press enter, now does my graph look like the one that's given to us?
Hey, what'd you put on the Y scale?
0.5. I mean 1. See, it says right there? That's the scale. Okay? Oh, because you put -4 instead of -4.
Oh.
Hey guys, look at this real fast, okay? We're going to use this as a learning experience. What does that look like it says to you? Because to me it looks like it says 2x minus 4. Okay? Can you tell it's like a shorter sign? That's a negative sign. To us, that it doesn't really make a difference, right? To the calculator, it makes a huge difference. That's why there is a minus button, and that's why there is a negative button, because it sees it as 2 different things. Okay? So when you put this in, this has got to be a minus. It still didn't work. What did you do? Oh, look what I did. Put it in.
You got to minus the time sign. You're not minusing the time sign.
Oh, in front? I see what you're saying.
There you go.
Minus
There we go.
4. Does that make sense? Thank you. Okay? So what am I looking for here? It's all fine and good that now that I know how to put it in the calculator, but what am I looking for? If I have 2 things set equal to each other, where should I look? Where they equal each other. What's that called? Yeah, the intersection. I'm looking for that right there.
So do you do that trace?
I could do trace, but there's something that's even more accurate. Menu,
Table.
analyze. Look, intersection.
Oh, yeah.
It will find the intersection for us, won't it? Not the 0. Hold on.